Inverter.
Welcome to ClickMyProject.com. The title of the project is Unsupervised Noisy Sample Detection Method for Deep Learning Based Health Status Prediction. And the abstract of the project is due to rough environment or data acquisitions equipment failure, the machine monitoring data may be contaminated with noise, which may lead to generation of noisy samples. For the widely used deep learning based prediction model, some noisy samples, that means which low intensity noises, may improve model generalizations, while some noisy samples with high intensity noise may hamper the prediction models. In this process, CMAPS dataset is used to find the health prediction of the turbo engine. The dataset which contains information about the sensors and remaining useful lives of the engine cycle. In this process, we propose the deep learning methods such as long short-term memory neural network and artificial neural network algorithms are used to test the remaining useful life of the turbo engines. The effectiveness of proposed method is verified using the simulated turbofan engine degradation dataset and a real miling machine monitoring dataset. Finally, it will generate the results in terms of matrices like accuracy, precision, recall, and FN score. And the flow diagram of the project is, first we need to start the program and select the CMAP.csv dataset. Then we use the sample dataset in our console working directory. After that, it will move into data preprocessing. In data preprocessing, we are going to find the engine health by increasing the cycles of the remaining useful life data. Then it will apply. Then it will move into label encoding. In label encoding, we are going to convert the string values into binary value of the specified label in our dataset. Then it will apply it into data resampling. The data resampling which is used to increase the accuracy of our system. Then it will be implemented into classification model. In classification, we are using two different types of deep learning algorithm, like long short-term memory neural network algorithm, which is one of the special case algorithm of RNN algorithm, and then our second proposed algorithm is artificial neural network algorithm. The both algorithms are used to classify our dataset and find the results in terms of matrices like accuracy, precision, recall, and F1 measure. The program was successfully executed in Anaconda Navigator Spider IDE, and these are the result of our engine health RUL prediction. So in this process, we are using CMAPS dataset. In CMAPS dataset contains train dataset and test dataset and also RUL text data. So in that, the process was considered as 5 set of modules like data selection and loading, data preprocessing, data resampling, model selection, classification. So in data selection and loading, we are going to read the train dataset and test dataset and also RUL dataset as an input in our process, and then it will apply into preprocessing technique. In preprocessing, we are going to group by the dataset based on the engine and maximum cycles of the engine. After that, add the remaining useful life by ignoring the maximum cycles of the engine. Then correlate the dataset by increasing exponential weighted moving, and find the health based on the RUL and exponential weighted moving. So after that, applying the label encoding to convert the string values into the numerical value. Then it will apply it into data resampling. Before that, we need to select the independent variable and dependent variable. After that, we need to apply the independent and dependent variable into data resampling method. In data resampling, which is used to improve the accuracy of the data set. Then after that, finally, we are going to apply the classification method. In classification, we are using long short-term memory neural network and artificial neural network deep learning algorithm. The both algorithms are used to classify the dataset and predict the result in form of accuracy and precision, recall, FN score. This is the cannot determine health based on the engine cycles in training dataset, and this is the sample data of train dataset, and this is the cannot determine health engine cycle for the test dataset, and this is the sample data for health, and this is the distribution graph between the health and unhealthy and cannot determine data. So in health, it consists of 12,789 dataset, and unhealthy contains 275 dataset, and our not determined data contains 32 data. So this is our first algorithm, long short-term memory neural network algorithm. So these are all the summary result of long short-term memory neural network algorithm, and our algorithm which is achieves the accuracy rate is 94%, and this is the performance graph for LSTM algorithm, and this is the classification report for LSTM algorithm. So in that we are going to find the precision, recall and F1 score values. So precision means number of correct prediction, and recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. And this is the confusion matrix results. So confusion matrix which is going to explain the number of correct prediction and misclassification from the long short-term memory neural network algorithm. So our final algorithm is artificial neural network algorithm, and the artificial neural network algorithm will achieve the accuracy rate is 91%, and this is the performance graph for artificial neural network algorithm, and this is the classification report for ANN algorithm, and this is the confusion matrix for artificial neural network algorithm. And these are all the variables that we are used in our program.